Take it away, Ross.
Excellent. So I have to sit so I can click through slides, but hopefully, can everybody here who's in the room? Can you hear me?
Yeah. If you want, I'll be your page down, or if you want to walk.
That's where I'll page down. All right. So again, my name is Ross Kukulinski. I'm the founder and CEO of Yodlr. Yodlr is a browser-based audio remote presentation tool. In fact, I'm actually using Yodlr right now, and there's the URL here. And in fact, we've got a couple of people that from somewhere in the world are listening through and seeing the slides. So my name is Ross Kukulinski. In addition to founder and CEO of Yodlr, I am also organizer of Baynode, which is the Bay Area Node.js meetup. We usually meet in Mountain View or sometimes in Palo Alto. I'm also part of the Node.js evangelism working group. So if you're interested in Node, I'd love to talk to you. I'm a huge soccer fan, and you can find me on the internet at Ross Kukulinski or ross@getyodlr.com. So quickly, Yodlr is for easy virtual presentations. It's a web-based product that runs kind of in your web browser. There's no plugins, there's no downloads, no user accounts. Basically, you click a link and then you're in. We've got high quality voice chat, audio recording, file sharing, and support for PDF and PowerPoint presentations. In fact, this is we're looking right now at a PDF presentation that I uploaded earlier today. So before I get talking a little bit more about our infrastructure and our technology stack, I want to see, is anybody familiar with the idea of a 12-factor application? Raise your hand if you've heard of a 12-factor app. Okay, not many hands here. So a 12-factor app is, the description for 12-factor apps are really, it's a good set of guidelines if you want to build a cloud-native, horizontally scalable application. So it talks about things like how to build in CI and CD, how to handle database and downtime, environment variables. So I highly recommend, if you haven't heard of it and you are building scalable web-based applications, or you're interested in getting into that space, to take a look at it. I think it's 12factor.net. So this is the Yodlr tech stack. So starting on the left-hand side on the infrastructure, working all the way to the right to the browser side client. We are a Rackspace Startup Plus customer, so all of our servers are in the Rackspace infrastructure. We're built on top of CoreOS, Kubernetes, and Docker. I'm not going to talk a whole lot about the infrastructure stack. I've been doing a lot of that at other meetups. I'm in the middle of doing a CoreOS O'Reilly tutorial, which should be coming out soon. So if you want to talk infrastructure, I'd love to. That's where my head has been at for the last month or so, but not for this talk. The database layer, we've got Redis and MongoDB. And then server side, we're very much a Node.js shop. We utilize Socket.io, WebRTC, and then Nginx for our load balancing internally within our applications. Client side, Yodlr is an AngularJS single page application powered by Socket.io and WebRTC. Any questions so far before I dive into these areas? Yes, go ahead.
Do you want me to stack it up a little higher so you can stand up, because it might be easier to hear?
Can everybody hear me okay?
I think it's
Cannot hear me okay.
silent. It's a little.
Sure. Yeah.
Here, hand me the. I can.
Sure.
I'm sorry to interrupt.
Yeah, that's all right.
So I asked the guys next door to stop the drilling. They're going to pause for a bit.
Okay.
Thanks.
I was wondering what that bass was.
Okay, there we go. Yeah. So no more drilling, and now you're standing.
All right. So I got a question in the back. Yes, sir.
Just one question. So you said you're using Socket.io on Rackspace. Are you using the cloud load balancer, or are you just using Nginx on your own?
Sure. So I'll repeat the question for the people who are remote. So the question was, are we using Rackspace's cloud load balancer, which is their load balancer as a service for our Socket.io? And the answer is yes. So we are using Rackspace's load balancer. It points directly to Nginx, and then that fans out internally within our infrastructure. Well, it goes through Kubernetes first, but the short answer is yes, we are using that. Are you having problems with that, or something?
I had a hard time getting long loop connections working with it, but that's good to hear.
And I'm happy to talk later as well.
Yeah, cool.
All right, so I'm going to dive through our tech stack in reverse. So we're going to start client side and work our way back to the server. So on the client side, so who was at last month's meetup? I wasn't here, but who was here? A couple of people. All right, cool. So there was a speaker last month who talked all about WebRTC. I don't want to go too far in depth with it, but basically WebRTC is a open browser standard that allows us to, as JavaScript developers, to get access to the microphone and speaker via the browser with no plugins or downloads. So that's actually how I'm recording my audio right now and streaming it out to the handful of people here that are listening. And WebRTC allows us to stream that audio from our browser to our cloud audio mixing infrastructure. The other key piece in our client-side infrastructure is Socket.io. So Socket.io is a real-time connection from the browser to our server that allows us to send real-time messages back and forth without having to do HTTP long polling. In other words, not having to constantly having a set timeout and request data every 5 seconds. Whenever there's a change, boom, it gets shipped out from the server to the browser, and we can update the user interface right away. So we use Socket.io for the real-time connection for our presence, the chat, and upload services. And then WebRTC handles all of the audio infrastructure. I do want to highlight for the people who are working with Socket.io, we are only using the WebSocket version of WebSocket protocol within Socket.io. Socket.io has the ability to fall back to long polling services. Because we know we're already using the latest generation browsers to support WebRTC, we decided we didn't need to support the long polling since all new browsers support WebSockets. Okay, so I want to talk a little bit about scaling WebRTC. So WebRTC is traditionally a peer-to-peer mesh protocol, meaning if we've got 3 browsers here, we've got 2 Chromes and 1 Firefox, and they're in a 3-way, call it a conference call or a 3-way data connection. Each browser needs to have a connection to every other browser that's part of that meeting. And these are not like connections through a central server. Each browser is physically connected, has a network connection to the other browsers, which for 3, maybe 4 browsers is really simple. It works really well. It's going to be low latency. You're going to have very performant connections. But the problem is when you get to 4, 5, 6, 10, 20, 100 nodes, suddenly this mesh network becomes a giant nightmare. And so what we've done in sort of something that is, I don't want to say common, but this is a way of getting around this in the WebRTC world, is having a scalable media server. So we've actually implemented our own cloud-based media server that does all of the audio mixing and all of the distribution, and that runs entirely within our cloud. So what that allows us to have each browser to connect directly to the media server. And that means we can offload all the network connectivity, and all the heavy-duty audio processing is done in the media server. Any questions before I move on? No hands up remotely? No hands up. All right. So back to Socket.io and Node.js. So Socket.io again is built on top of WebSockets and allows you to fall back to long polling. Socket.io describes the network protocol. So the most common application server that supports Socket.io is Node.js, but I do know that there are implementations in PHP. I think there's a Java one. There's some other implementations of the network protocol. We've been a Node.js shop, gosh, since about 2011, 2012. Who's familiar with Node.js? Like, who's built something with Node.js? Okay, about half the hands here. So those of you who are not familiar with Node.js, Node.js is a server-side application technology. You can kind of think of it, if you're from a PHP stack, it replaces your Apache and your PHP. If you're a Java stack, it replaces Apache Tomcat plus Apache in terms of rendering your content. Basically, you write JavaScript code like you would for your browser, except you run it on the server side. And that allows you to do very real-time applications. And one of the things that, and Node.js uses the V8 JavaScript engine, which is the same engine that runs in your Chrome web browser. So it is really fast. And one of the things that V8 and JavaScript or Node.js in general is very good at is maintaining many, many concurrent connections. So if you are familiar with like Apache, every time there's a new connection, it spawns a new thread, which means that it takes up a block of memory and it requires additional resources. Node.js does not spawn up a new thread for every connection, which means that it all runs inside of an event loop. Event loop versus context switching, a whole other discussion. But essentially what that means is that Node.js is really, really good at holding lots and lots of connections. So that means if you've got a lot of mobile clients, you have a lot of web browsers, you've got APIs, you've got persistent connections, streaming connections, like I'm connected to the chat system, and there might be 100 people or 1,000 people or 10,000 people connected to those sockets, and they need to stay open at all times. The downside of Node.js is that it's single-threaded. That means that a Node.js process will consume at most 100% of a single core. So you've got your big server that's got 16 cores. Your little Node.js app will only use one of those 16 cores. The way around that in Node.js is to run multiple instances of your application across the cluster. There are built-in ways in Node to do that. In our infrastructure, since we've Dockerized all of our applications, we just run multiple Docker containers across our infrastructure. And that's how we're able to take advantage of multi-host and multi-core. Question?
Sure. As you said, correctly, Node.js is single-threaded, but some people are running, say, the JavaScript engine on top of Java JDK8 or the Natural, which has, as I understand, support for clustering across multiple threads and clusters. Have you experimented with anything like that?
We have not. We're not a Java shop. We've sort of been a Node.js shop for a long time. I am familiar. Like I do have a client that is looking at. They're a Java shop, but they want to take advantage of some of the things of Java and the V8 engine. I would also say if you're in Java, why not use Scala? Yeah, someone's cheering on. So I'm not very familiar with that technology and how they're doing it, and I don't know how it performs, how it works. But there's always people, very smart people doing cool things. Are you using it?
No, but I've seen the same thing apply to JRuby, because standard Ruby implementation that we have some JRuby applications which are using all the threads across x82 core machines. I imagine they're using some of the underlying principles to do that for JavaScript. I'm not familiar with what exactly that is. I understand there is distributed event graph which gets spread out to multiple event groups, one per core.
Cool. All right. So Socket.io in production. And again, this is very much geared towards the Node.js world, so I apologize if you're not doing Node stuff. One of the big things for Node.js, and this may tie back to your question, is that you need to enable sticky load balancing with your load balancer if you are using XHR polling or JSON P polling in the Socket.io infrastructure. Basically, if you're not using just vanilla WebSockets and you fall back to the long polling, you need to make sure that your load balancers, whether that's your load balancer as a service, or if you're using things like Nginx or HA proxy, you need to make sure that you have sticky load balancing. Basically, each time a browser makes a request, that particular browser should always be routed to the same Node.js server. That Node.js server has got the stateful information about that connection, and it knows what requests or what data has already been sent to that browser and what hasn't been sent. In our case, we ditched long polling, so we don't have to worry about that. For Socket.io, you do need a database layer on a couple of these conditions. So Socket.io has built-in rooms and built-in broadcast, meaning you can, from your browser, you can broadcast a message to the server, which then gets automatically rebroadcast to all of the connected clients, either in total in the server or in just that room. And this is all, it sounds scary, I just said it comes from the browser, but the actual logic is server side, so it's not a security threat. But if in order to do that, you do need to have a persistence layer. Basically, Node.js, a single application, you've got two instances of your application, and the first one receives the message, and it needs to send data to the other server. The only way to do that is through a database connection. And the same goes for authentication. So if you want to have authenticated connections and sort of verify who the people are when they make their Socket.io connection, the recommended way is doing that with JSON Web Tokens, or JWT. And then Socket.io also has support for custom middleware functions to do additional authentication or authorization steps if you've got advanced logic. So when it comes to Socket.io databases, Socket.io by default uses a memory store, which is only for that particular Node.js application. Redis is by far the most popular database store for Socket.io. I do want to make a big caveat that the messages that if you're using Redis as your data store, messages are not persistent, meaning if you have client A connects and sends a chat message, hello world, and then sometime later client B connects, client B will not get that hello world message. So if you want to have that as a persistent message, you have to go and implement your own additional data store on top of the broadcast mechanism. You can write your own additional DB support. Now that we're here at Socket.io or at RethinkDB, there is a Socket.io RethinkDB. I haven't played with it yet, but I was reviewing the code and was pretty impressed by it. So That's definitely an option. If you are a Mongo shop, Socket.io Mongo was last updated over 2 years ago, so probably should not use that one. That's definitely a sad face for us. Questions so far? Yes, sir.
TCP port numbers are only 16 bits. Do you end up running out of them?
TCP port numbers.
If you've got all these long-lived connections and you're scaling massively.
So one, we're not at that size yet, but it's a good question. And most of the top level load balancers, whether you are running your own DNS load balancing, where you've got DNSA records that point to multiple top level load balancers, or using a load balancer as a service, like we're using Rackspace's, AWS has got their ELB stack. Those systems all support many connections. And so then it's a question of how many of your physical Node.js servers do you have underneath the hood. And so then it's just, you need more ports, bring up more connections. The reality is, though, is that you're going to hit performance limitations in your application before you hit the number of port limits. So Node is really good at.
So Node is scalable, but not stupid scalable.
It's not like you're writing a C program that does this. Like there is V8sec, there is overhead, but it is much better. It is much better at holding open those connections than an Apache system that spawns a new thread for every connection. Good question. Yes, in the back.
I just want to add that it's kind of a common misconception that you can run out of ports with the HTTP connections. But if everybody's coming from a different IP, then you don't actually have that problem. So you could encounter it in a test environment if you have like a client server blasting a server. But if you have a bunch of clients coming from different IP addresses, then you don't have a TCP is unique by IP and port. And so the fact that there's unique source IDs means that you don't actually have as much of a problem there as you might think.
I think that you're right, but I think that they're also within. I know I've been in Linux land, so I'm like I think Linux within the kernel has a limitation about the max number of sockets, and it's a configurable thing. And so probably more likely you're going to hit an Emacs sockets problem before you actually run out of ports.
You'll also hit the same problem with your load balancer. So if everybody's coming from a different IP, but then suddenly everything comes from one IP from your load balancer to your backend, then you kind of just take the data there.
Good point. Any other questions?
The problem is going to be the amount of memory that is tied down with the TCP retransmit limits.
Sorry, could you repeat the question?
The biggest problem for supporting many connections on one server is the amount of memory that is tied down with effectively idle because of the size of the TCP IP transmit window. Because that is a constant setting for the entire system. It doesn't matter whether your socket is highly active or almost idle. Most of that memory is inactive.
You had a question?
Did you guys have to do anything different when with connections being flaky, intermittent, or like failure of the node servers itself?
So definitely, I mean, I don't write perfect code, so our servers crash. Right. They crash in staging, and they would never ever crash in production. Yeah, absolutely. So flaky connections, especially with mobile clients. So we're working on an iOS client right now, which has to deal with jumping between mobile networks. So sometimes you're on a 3G connection, then you get upgraded to 4G connection, and then suddenly you're upgraded to Wi-Fi, and then you get 1 bar because you're on Verizon and you hate your life, right? So definitely for a lot of that, Socket.io magically handles that. It's not really magic. Basically, each Socket.io connection has a unique ID. And so the client, if it happens to get disconnected, it will try to reconnect, and it'll say, this is my ID. And oftentimes by reconnecting with that same ID, you'll sort of reconvene your session. We have, for the most part, we try to take as best advantage of that as possible. But our standard fallback, because we've built our application that if you refresh, it comes right back up. Oftentimes the fastest thing for us to do is essentially do an internal refresh of, all right, wipe our state, reconnect, re-get all the data, and we're back up. So we've sort of failed, we've built our system to fail fast in that case, because that is a common problem.
Cool, thanks.
Other questions? Cool, all right. So who's familiar with Redis? Just raise a hand. Okay. So Redis is a really simple key value store. One of the really interesting things that comes with Redis is it has built-in pub sub. meaning you can have client A publish a message that gets rebroadcasted to anybody else who's in that channel or in that room. Redis is really, really easy to set up and to build with, and it's really fast. But building high availability with Redis is really a pain in the neck. It does have support in quotation marks for high availability, depending on how you define high availability. And it's also not really geared towards persistent or long-term storage, which really gets to our next thing, is that in our database layer, we do have long-term storage. So we have premium user accounts that have credentials and permissions. We want to store historical anonymized data about how people are using rooms and how many files are they uploading and how much are they actively talking. And so we need a persistent place to store all of that. And so we've been using MongoDB for that persistent storage layer. And then we've been using Redis as that temporary storage of what the current real-time room information, as well as the socket.io performance or persistence layer. So the room that we're actually in, once we close this tab and everybody else leaves, all of the data that's in this room all gets destroyed. It's an ephemeral room, so once you leave, it's gone. And so we store all that in Redis, which is nice because Redis is good at forgetting things. But we do need to have this long-term storage for our applications. One of the things that Mongo is not great for and doesn't really have a nice built-in support, which is PubSub. So even though we're a small development shop, we're forced to sort of have these two different databases that we have to manage and worry about. So here's a crazy idea. What if we had a database that had persistent storage and had PubSub capability? So I've been watching RethinkDB for a really long time, and this is not a paid advertisement. I want to I know that they had no idea that I had this slide. And the company that we spun out of has a bunch of experience with CouchDB as well. And both these platforms have support for this idea of a change feed or a changes, where you can make a query and then you can say, give me the query, and then let me know anytime that query has changed. A new record has been updated, or a record that I've already received has been updated. And so I think for us, in the coming weeks, months, something like that, we'll probably actually completely nix our Redis and our MongoDB, and we will probably switch to RethinkDB, assuming we continue to be as happy with it as we are in our dev infrastructure. So this is probably where we're going in terms of our new tech stack. Question?
Do you see any challenges to that?
Say that again?
Do you see any challenges to that?
Yes, there definitely will be challenges that I think as nice as it is having two different databases, or as annoying as it is managing the two different databases, it does mean that if, for example, our MongoDB cluster goes down, which we go with a hosted provider, so it should never go down because we pay the money to never go down. But if it does, we basically fail open in that case. So you can create a free room without any authentication. And if Redis goes down, we're in trouble. But switching to, I think, a RethinkDB cluster, which I don't want to be selling RethinkDB, but they've made the clustering and high availability of the cluster really easy to manage. It's one of the things that I had my aha moment working with it. But again, now we're down to a single point of failure. So that's something that I think we'll have to play with. I also haven't done much performance testing. I don't know how RethinkDB is going to stand up under the same load that we put our Redis cluster under. And so we may end up actually running two clusters. We may have one cluster which manages all of the persistent storage and another cluster that runs and manages the sort of short-term data. And that's, I don't know the answer because we haven't really started experimenting with that, but that'll be part of our dev and then staging infrastructure for a while once we experiment with those couple of things.
So in your proposal, do you plan to use the in-house clustering, but I know you come with that, or do you plan to shard it yourself?
We're up in the air. So we haven't decided yet whether we will host it ourselves using the built-in tools, whether we'll use, I think there's only one DB as a service, which I think is compose.io. Maybe someone from Rethink can tell me that there's another one. I know there's one supposedly in beta, but they haven't posted anything. I prefer, and I think I got the next slide. Yeah, database as a service or self-hosted. So right now our MongoDB is hosted by ObjectRocket, which is owned by Rackspace, so we get it for free. Yay! Our Redis is self-hosted, and in general, I sort of feel like if you don't have a designated database engineer or someone who's got significant experience with databases, go with a hosted platform. Like if you like your database is not, like the real-time stuff is not a critical piece of your infrastructure, of your business logic, let someone else who knows how that stuff works. And I think that largely comes down to what you're building in your application stack. And that ties into this next slide, which is, if we were to start all over again, or if we were building a slightly different application, would we actually run with a custom-built Socket.io with Redis infrastructure, or would we go with a software as a service sort of pub sub / messaging system? So PubNub, Firebase, Pusher, those are all software as a service messaging and distribution. They're all globally distributed. They've got huge teams. They've got really deep investment pockets. Probably might be a lower TCO and total cost of ownership, depending on your application. Of course, you always are concerned about vendor lock-in. So you could also argue that picking a database is also a vendor lock-in. So it depends on, I think, how important is the real-time messaging, or that connection. How important is that to your critical business infrastructure? And that should help lead you to whether or not you're going to own that in-house, which means you have to have the engineering support for that, or you're going to leverage somebody else for that.
Are you also looking at the competitive aspect of it? Like, for example, for database, like RethinkDB, probably they don't care much about your space, but the other guys, would it be easy for them if they think your stuff is profitable to go Amazon, for example, and start doing things, right?
I'm not sure I fully
Like,
understand.
for example, you're doing some pub sub stuff, right? So PubNub probably it's easy for them to replicate what we do, right? If they want to. But the RethinkDB probably don't care much about that. So from that point of view, there's a bigger distance for RethinkDB to kind of compete with you. Are you looking at that or not?
I mean, we're evaluating. I mean, at the end of the day, we're an audio company. So like, we care about the real-time and high-quality audio connection to everybody's in the room, whether it's 4 people or it's 400 people or 4,000 people. So that's like, for us, that's our core business thing. To a certain degree, the rest of this is sort of sugar on top. It makes it for a better presentation. But at the end of the day, if you don't have a presentation with good audio, it's not worth having the meeting. So for us, our true expertise is the audio stack. And then now we're trying to make it as easy as possible. So in our case, the pub sub stuff, it's not really critical to our business. The audio infrastructure absolutely is. So I think for us, that's sort of where that breakdown. And I think we're on the borderline of, should we build it ourselves, or could we leverage some other pub sub infrastructure? In this case, when we first built this, it was a 3-week sprint by a 2-person dev team to build an internal tool. So we wanted to, as quickly as together, put something together, and that was like the first version of Yodlr a year and a half ago. And so since then, we've sort of kept building on, well, we've got this thing that works, let's keep building on top of it. And I think that's how we've gotten here. So that's why I had this slide, which is like, if we were to start all over again in a brand new world, yeah, we might consider building on top of one of the existing pub systems. And I think if you're doing an Internet of Things style hardware company, this or building on top of a WebRTC stack would probably be very smart for those data channel connections. That's my take. The last thing that I've got here, and this is what I've really been talking about at a bunch of other conferences, but I did want to touch on it because I think it's important for sort of real-time applications, is real-time DevOps. So one of the things that I've experienced in building applications, a lot of times you'll build an application and you put in, someone's playing with me. Stop changing the channel. All right, so in the real-time DevOps is you will build out logging infrastructure. So you can see all the logs from your applications, but when you get to a certain scale, we've got a certain number of instances, logs really just become noise. And you really need to have insight into what your applications are doing. And that insight is oftentimes some sort of metric system. So measure everything. For us in our infrastructure, we use StatsD plus Graphite and Grafana, which are all open source metric aggregation tools. That needs to be a part of every application you build and all the way through. So from the dev to your staging to your production infrastructure, you need to see those graphs. If you can't measure it, it didn't happen, which means you can't actually make it better. Also, deploy early and often. So as part of your continuous integration and continuous deployment, which you all have, right? You should be able to really get code from a developer into test and into staging and into use by somebody. Maybe it's not actually in the World Wide Web, but you have it that is suddenly accessing and handling data so you can see just how well it performs. The faster that iteration cycle, the faster and easier developers can build and experiment. And then finally, we love Docker, Kubernetes, and CoreOS, which allow us to build and scale our applications very easily. outside the scope of this talk, but if you're interested in any of those topics, I would love to talk on that. And that is all I got. Thank you. More questions?
Any plans to add video?
And the question was, any plans to add video? So at this point, we are focusing on audio only and the ability to have the files directly in the browser. We found that for small conferences, like if you've got 1 or 2 people, then video is pretty important to have that sort of one-on-one interaction. But as you get to more and more people in your meeting, it just becomes a whole pile of talking heads. And so we're trying to optimize for those larger conferences, those larger meetings, and making it easy to get other people involved involved in that conversation.
Sure. What about integration with Slack?
We have Slack integration and we have HipChat integration. So if you want to use, the Slack, all of that's right now, you can find it all on our blog, which is blog.yodlr.com. So in slash, we don't have a slash command yet. You can ask for it. In the meantime, you can use webhooks for that. If you use HipChat, we're in Atlassian's HipChat add-on store. You can find us as Slack or as Yodlr. Question? Yes.
What does your CI look like? Like in terms of like, do you give a push and then like some tests happen? Is there an auto deploy process?
Absolutely. So, so the question is, what does our CI environment look like? So when a developer, so we're a pull request based organization. So if a developer wants to make a change, they submit a pull request to GitHub. So then that automatically triggers a Jenkins build that runs essentially unit tests on whatever that service is. And I guess I didn't mention this, but we are I hate using it, microservice, but like we're a small service company. So each functional unit of our application is a separate service. So the persistence layer and the socket IO connection is one. File uploads is another service. The audio system is another service. So each one of those services has its own unit tests that are run on every developer's pull request. If my co-founder creates a pull request, I sanity check it and merge it, or vice versa. Once it's merged into master, Jenkins does another build, then it does another unit test. It deploys, publishes the Docker container. And all of this is happening inside of Docker containers. So we have Docker containers that build Docker containers. Inception, yes.
Is every service in a separate container?
Yes, every service runs as a separate Docker container. Back to your question, from once it's done with the test and the image has been pushed to our private Docker registry, that triggers a staging deploy. So that using the Kubernetes rolling deploy, it does a rolling deploy to our staging infrastructure where it sits until someone manually decides, yes, it's time to do a production deploy. Probably in the next 2 weeks, we're going to roll out canary deploys. So there will be a canary staging deploy where maybe approximately 10% of our staging services will run the new version, and until we're happy with that, and then we'll do a full rollout, and we'll do the same canary rollout for our production.
How do you do your private registry?
We just run the Docker private registry.
The hub.docker.com.
Yeah, we run our own internal version. Yeah, last question.
Just curious, do you, as far as the content, is that from a business perspective, from a business model perspective, at some point you have to worry about it, meaning what content do you broadcast and where
the short answer is yes, of course. And I'm sure we've got a plan to figure that out. But that's part of our top secret business planning. That's a good question, though. All right, I think that's all the time I've had. Thank you very much. I'm happy to talk afterwards.